I still have a lot to talk about. I do have like kind of 2 chapters to go. They're not as long as this one. Let me get you the link to this course, which is, get out of my way. So this is the link to the lab. This is where you're going to find the recording tomorrow or the day after. But this is also where you're going to find the materials. Okay? So when you access it, if you don't have a cloud account, you need to create a ClickHouse cloud account to access the content, but the content is free. Then you just click on enroll over here. And you have the slides and the labs in the BigQuery workshop. You click on start. And then you go to lab. So the slides are here. So if you have any doubts, you want to check something. And there is a lab 1.1, explore data in BigQuery. You might not have a BigQuery account, so you can just skip this one and come back later if you want. Please go to lab 1.2. So lab 1.2 is, we already give you, yeah. Okay, no, so actually this one is, oh, sorry. Yeah, okay. It's there, but it's just hidden. So do lab 1.2, but just go straight to 6. So you create the cloud account and you can play with the data that is already in GCS. You don't need to export anything. We have the data already there for you. You can use our own GCS files. Okay, so let me write here lab 1.2 step 6. I'll give you 9 minutes to access all that, enroll, and do from step 6 to step 11. Yeah, let me write that down. Six, seven, 8, 9. Resume. Okay, after I get you all started with the labs and stuff, I'll be back and I'll continue. I'll talk about schema design, primary key, data types. Then I'll talk about data modeling. So we go back into joins and like, why is it important? And finally, I do some closing remarks. I have a very nice demo with a 1 trillion rows data set. So like real, like large size data set. I think it's about 8 terabytes of data to really compare ClickHouse and BigQuery and how long it takes to run like a simple query. Okay, I'm gonna go fetch some water. I'll be back in a bit. Please get some water as well. Try to follow the labs. If you have any questions, just put them in chat. I'll be back in a bit. Yeah, the S3 table function works for data stored in S3 and in GCS. The GCS is actually just an alias to the S3 table function, which is funny because we don't have a GCS cluster that's an alias to the S3 cluster table function. But yeah, it is what it is. I would just use S3 table function. I think that's kind of becoming the default, and it just works. Um, Could be. Which website are you talking about? One of the things you need to do when you access the URL I gave you is to click enroll here. Yeah, just use this. And now that you're already logged in, you're probably going to see an enroll button here that you can just click. Let me know if it works for you. Yeah, perfect. No worries. Yeah, this UI is not the best. Unfortunately, it's just the LMS, like the learning management system we use, and there's not much we can do about it. We really would love to rework it, but yeah, for now, there's not much we can do. Let it work. Okay, I'm sure many of you won't have completed all the steps, but to me, the most important thing is to make sure you know how to get there later. So I can actually teach you more things, and you can just take some time later today or tomorrow to actually go through the content. What the content's going to walk you through is basically what I'm going to talk about as well. So like creating the service, running some queries, and then as we go through the schema, it's going to go, okay, let's create a table with the right data types. Let's optimize it. So it walks you through some of the problems we see out there and how to write some queries. So like just few different examples. And then we talk about, okay, like remodeling the data, denormalizing, doing the joins with the dictionary, etc. Uh, not sure what this means. Wojciech. Also not sure how to pronounce your name, so sorry for any mistakes. No worries. Oh, good. Good. Let's talk about schema design. So when I was doing my demo, I basically said, okay, then I export the data here and I come here and I create the table, right? But why did I choose badges? Why not posts, users, votes? Like, where do you start when you're doing a migration, right? Start with the simpler tables, okay? That's how you're going to make some mistakes. It's going to be faster and easier for you to correct them. And then when you are more prepped, you can start tackling the more complex ones. Define the ClickHouse data types. I had defined them previously, and I'm going to walk through. Define the primary key. What is a primary key? Is it a unique thing? Load the data, run some queries. Let's go. So here are some tables: vote types, post types, badges. Vote types and post types are just too simple. So let's get badges. I think this is a good one for us to give it a try. So we have an ID, that's the badge ID. We have the user ID, which is the user that got the badge, the name of that user, the date it got the badge, a class, and a tag base. Actually, there's no data in there, so let's not bother. We can look into the original schema of BigQuery. We have ID, we have name, integer, string, timestamp, integer, and we can use those to actually model things in ClickHouse. What you're going to see is that they are all nullable within BigQuery, but within ClickHouse, we try to avoid making columns like nullable. So there's a schema inference in ClickHouse. So if we go back here and we just do a describe, there you go. That's my schema inference, like all the columns I had, but now with the ClickHouse schema. By default, ClickHouse is going to give you back nullable because it's just more compatible with external data sources. But as you write your own thing, we actually recommend you to not use the nullable. We also recommend you to tune each data type to the smallest unit possible. So for example, an int 64 could be actually an int 32. Data time 64.6, I don't think we need nano precision anywhere. So just data time is probably enough in this case. So we go from here and we start playing with it. So avoid nullable columns. They add storage and computing overhead without any benefits in the most cases. What ClickHouse does internally is it sets the default value. So for a string is going to be an empty string. For numeric is going to be 0. If that is going to impact anything, then use nullable. That's okay. But if you can, just leave an empty string there or just set the default to -1, why not? It's going to make things faster. Again, we care about fast. Use minimal precision for numeric types. So check the expected mean and max values. We actually do that in the labs. Avoid float, use decimal instead. We do all those things in the lab. Minimal precision for date types. So date and date 32 for just the date. And date time, so the 32-bit for second precision and the 64 for nanosecond precision. In this case, date time would be more than enough. Low cardinality. So if a column has less than 10K unique values, we suggest adding the low cardinality data type. This internally in ClickHouse creates kind of a map. Okay, so a value is mapped to like an integer, and then it uses that integer as actually the value that's stored. So it optimizes a lot of things internally, making ClickHouse even faster. All right. So one thing you can do is you can actually check. Let's check name. That's not happy with it. Oh boy. Describe unique name. No, that's not going to work. Okay, so there are about 7,000 unique badges, right? The name column has only 7,000 unique values. So we can definitely use low cardinality for that. Enums for data validation. So if you want to validate data, you can use enum. Otherwise, you can just use uint8. That's also a small type. This is a nice query that kind of gives you the min, the max, and the unique for all the different columns that you have. Oh, sorry. I thought I was going to be able to copy from here. Let's see if I can do it. It's not planning on running this one, but maybe it just works out of the, okay, I need the base URL. Yeah, so this is what I usually use when defining my data types. It's like, okay, like what is the main ID, the max ID? So this doesn't have to be a signed, it can be unsigned. The date, the min date is 2008, so we don't need like a lot of old precision. Like, do we really care about the nanosecond that someone got a badge? Like, I probably don't even care about the hour they got the badge, mainly the day, but okay, we have the hour. Let's skip it. Yeah, so you just go through, you rationalize through it and figure out what data types you want. So yeah, greater than 1, you win 32, unique, less than 10,000, so that's a low cardinality. Seconds is enough for date. So you go here, you change all that. There's a data type mapping, so you can actually look. We do have this migration BigQuery data types link. So BigQuery versus ClickHouse. Let me give you this. That's probably an interesting one, even though it's in the slides and in the lab. So it's like comparing BigQuery with ClickHouse in terms of concepts. And one of the things we talk about is the data types. So we kind of map them. So numeric becomes decimal, big numeric is big decimal, Boolean, bytes, a fixed string, date time, float, geography, JSON, string, etc. Great, so we got the data types right. The next step is to define the primary key. So don't use the BigQuery primary key right away if you have it defined. If you're coming from PostgreSQL, MongoDB, don't use the primary key that you have right away. Primary keys in ClickHouse are different. They're not unique. They don't define relationships. You can have unique primary keys, but that's a different story. Like it's a specific use case within ClickHouse, and you need to treat it as so. Okay? What the primary key is in ClickHouse is a way to define the order of the data in disk. Okay? It's going to affect compression, it's going to affect query execution time, and it's going to make things faster. All right? So how do we choose them? We choose columns that align with the common features. So to define your primary keys, you need to look at your queries. What are the where clauses? So let's look into the where clauses that you have. See what are the columns that are used to filter the most. And those are the columns that you should use in your primary key. Columns which exclude a high percentage of total rows when filtered. So where clauses, they're very effective. Columns likely to be correlated with other columns in the table. So in this case, no, we don't have a good example in here, but if you're talking about addresses, probably postcode is related with your zip code, right? Yeah, actually, this is the same thing. I'm just trying to remember about columns that could be related. Yeah, nothing comes to mind now. Sorry, it will come in a bit for sure. But the idea is that if column A has something to do with column B, the fact that they are together is usually a good thing, because when you put column A and then column B, like the values are going to be the same. They're going to be stored contiguously, and it's going to be better for compression. Group by and order by operations, they are more efficient for columns in the primary key. So that's a plus, not really important. The where clause is what makes the difference. So let's think about some common queries. What are the top 10 badges? What are the 10 rarest badges? The badge distribution over time by month. What is the badge distribution? What are the top 10 users with the most badges? So on and so forth. So we look into the group bys, the where clauses, and we see what are the columns that are mostly used. So in this case, good candidates are going to be the date, the name, and the user ID. So those are 3 candidates, but what is the order that I'm going to define them? So after identifying the subset of columns for the primary key, they must have an order. In general, the best order is ascending of cardinality. Okay, so the lowest cardinality column first. So 1 and so forth. If you're not sure, test a few variants, run the queries, and see if anything changes. So in this case, if we have date, name, and user ID, what should be the order? Anyone still alive in there? What should be the first column? Yeah, so the first column should be the one with the lowest cardinality. So the lowest cardinality here is definitely going to be name. We even put like a low cardinality in front of it, right? So you would start with the name, then probably the user ID, and then the date. So date is really nice, but it's often at the end. Again, it depends a lot on the queries, and you would probably need to test. But we do have 2 names, 3 user IDs, and a few. So they are like use it equally, I would say, in this case. So I would put name, user ID, and date. All right. Good. So you learned about schema and you learn about primary keys. So a word on loading data. So ClickHouse table functions, I told you that's one way. We played with that in the labs, and you're going to play more. File exports, not very common in ClickHouse, but sometimes you already have it in place. You already have those files being exported, and then you just load those files into ClickHouse. ETL, like tools, so a one-off book, and then you do incremental loads, and you can consolidate data from multiple different sources. And CDC, that stands for Change Data Capture. It's becoming more and more common term these days, and basically means synchronizing the data between the 2 databases. I think for BigQuery, we don't see a lot of people that kind of uses both for the same use cases or even the same data sets. So when you migrate from BigQuery to ClickHouse, you probably just leave your data in ClickHouse and forget about BigQuery. That's different if you're talking about PostgreSQL, MySQL, MongoDB, where you have a use case for having transactions within those. And then you have the analytics use case, so you want to keep them in parallel. So that's when CDC really shines. So loading from BigQuery, create the table, import from GCS. We talked about that. And then a few tips on writing queries, right? So select name and count. So what are the 10 most common badges, right? Select name, count stars, number of badges, from badges, group by name, order by number of badges, descending limit 10. Gives you all the badges with the count that it has. This is ANSI SQL just here. If I copy and paste this same query into BigQuery, this is just going to work out of the box. Okay, it might complain that count should be all uppercase because it's a function, and I think they use all uppercase, but it will work just as it is. But ClickHouse gives you some extras on SQL. For example, you can just do count without the star, right? That's a great way. Like just remove the star. It's way quicker. It works. Another thing that's super cool is like in many cases, you need to do count star as number of badges. So you can actually reference it later on the order by. No, ClickHouse allows you to do positional reference. So you just say, okay, order by 2. And this is 1, this is 2. So it's going to order by count. Okay, so those are some of the nice small things that ClickHouse is going to offer you when it comes to its SQL syntax. Some functions. So we could do a distinct user ID. I think that's actually how I did the example in the query when comparing times. Another way to write it is just unique user ID. That's exactly the same as distinct whatever. Oh, this is a really, really cool one. So I want the number of badges, like I want the mean, the max, and the average badges, okay, per day. So what is the day that we had the minimum badges issued to a user? What is the day that we had the maximum number of badges issued to a user? But I also want the value of the mean number of badges and the max number of badges, and just the average overall. So to write this in SQL, this would be very complex because I would need to do a first calculation of everything to then actually be able to get the day with the mean value. In ClickHouse, we actually allow you to use argmin. This is a function that's a very, very hand function, which has its counterpart, the argmax function. So here I do a mean count, which is straightforward. Just give me the min. Okay. And I do an argmin day on the count. So it's like, give me the day where the count is on its minimum value. And the same thing for the argmax. Give me the day where the count has its max value. Okay? One caveat here is that if there are 2 days with the same mean value, it's just going to pick one of them. And if there are 2 or more days with the max value, the same max value, it's just going to choose one of them. Okay? So it speeds things up a lot. But on the other side, it gives you this not like all the days that have the max count. All right, but it's pretty short query to write, like pretty straightforward. If you would actually write this in PostgreSQL with BigQuery, like it would be a way longer query. Good. With that, I'm done with the ClickHouse schema. I'm going to leave the lab for later if we have time.